Okay, so we're done with capacity, volume. So today we're going to talk about, first, we're going to talk about the difference between weight and mass. And there is a difference. A lot of people tend to use them interchangeably. But weight is actually the measurement of the force of gravity on an object. Mass is the measure of the amount of matter in an object. You might look at it and think, well, that's kind of the same thing. And yeah, the more mass something has, the more it's going to weigh. That's definitely true. But the biggest difference is in the way it's measured. Weight is measured off a spring. A good spring, the amount of force it takes to stretch it is directly related to how far it's stretched. So the further you stretch it, the more force that's being applied to it. So you can use it to measure the force of gravity pulling on an object. So you take this spring, and what they'd usually do is it was encased in something like this, and they'd have a scale. Now a scale is just a metered set of numbers, is what all a scale is. They call this device a scale, but it's a scale because it has a scale on it. It's a scaled spring was actually the original name of it. It was a spring with a scale on it that allowed you to see how far it had stretched. So then you're going to hang your object on the bottom of that scale, and that spring is going to stretch. And the amount that spring stretches tells you the weight of that object, because that measures the force of gravity pulling on that object. Mass is measured, so this is a scale. Mass is measured with a balance. What a balance is basically a teeter-totter that is perfectly balanced. It'll sit there and balance perfectly with if you don't put anything on it. So then you put your object you're trying to measure on one end, and the other end you put known masses. And when it balances, whatever the known mass is here, that's the mass of this object. And you might be looking at it thinking, well, both of those involve gravity, and they do. But if gravity changes, for example, let's say you go to the moon. On the moon, gravity is 1/6 what it is on Earth. So this here is going to stretch 1/6 of the distance. It's going to weigh less because gravity is going to pull on it less. Over here, gravity is going to pull on this less too, but it's also going to pull on the known mass less. So the mass doesn't change if the gravity changes. No, they won't float away. There's still gravity. There's not total absence of gravity. But later, if on the moon, if you jump, you don't keep going forever, but you'll jump a lot higher and it'll take you a lot longer to come back down.
Is it possible to jump high enough to break atmosphere?
To escape the gravity, it's possible, but not humanly possible.
Okay, you couldn't jump on the moon.
No.
Have fear of losing gravity.
No.
Just
you might be able to
float over the mountain and just.
It might be possible to launch a ball or something and get it to escape the gravity. They call it escape velocity. You have to have an initial velocity large enough to escape. A human cannot generate that type of initial velocity. Now, on Earth, gravity is relatively constant. You actually look at the Earth. Most people think of the Earth as being round. It is not. It's actually oval type shaped. This is the equator here. And these are the poles, here and here. Gravity is actually slightly less at the equator and slightly more at the poles. For a couple reasons. One, But, you think of it, you spin a ball, it kind of gets oblong. That's kind of what the Earth is. It's spinning. And people don't realize it is spinning really fast. The equator of the Earth is about 15,000 miles around, all the way around. And it makes that revolution in 24 hours. So if you think of that, 15,000 miles divided by 24, you're putting in, 625 miles per hour at the equator. So that's moving. So it makes sense that the world, the Earth, has become oblong because of that spin. What's that? Just like drag tires, yeah, the car will actually elevate because the center of the tire pushes out. So there's two reasons why gravity is slightly less. So one, you're a little bit further away from the center of the Earth, and two, you are moving at that speed, and it's kind of, you swing something around and it kind of tends to fly out. Same type of deal. On the poles, it's slightly less because you're not moving at that speed, and you are a little bit closer to the center of the Earth. A 200-pound person would actually change by like 5 or 6 pounds in weight from going from the pole to the equator. It's like about 3 to 4% is about all it is. But so since on Earth, since it is such gravity is very relatively consistent, we kind of we blur the lines between weight and mass. We kind of use them interchangeably. Now, in our standard system, there is a unit of mass. You've probably heard of it, but had no idea that it was a measurement unit. It is the slug. You may have heard the phrase, a whole slug, I've got a whole slug of those at home. A slug, that's where it came from. A slug is a unit of mass. One slug weighs about 32 pounds, by the way. In the standard system, we tend to focus on weight because, let's face it, what people noticed first was not the amount of mass in an object. They noticed how heavy it was when they went to pick it up. The fight against gravity. So weight was what was defined first. If you're looking at weight, what is our big unit of weight that we use? A ton. 1 ton is how many pounds? 2,000 pounds. Now this is actually what's called 1 net or short ton. If there's something called a net or a short ton, that implies there's something called a gross or a long ton. A gross or long ton is 2,240 pounds. Where did these come from? Why is there a difference? Well, the ton was originally used for measuring grain. And when you go to throw grain on a scale, you can't just dump a ton of grain on the scale. It's going to fall off the sides. So they actually had to put a container there to hold it. So the container that held about a ton of grain was about 240 pounds. So you think of it like your paycheck. You work 40 hours at $20 an hour. It's $800. That's your gross, but you don't actually get that much because they take out taxes and other stuff. So the net is what you actually get. The gross is the whole amount. 99.9999% of the time when you hear the word ton, they're talking about 2,000 pounds. I just wanted you to be aware that there is a gross ton out there, or a long ton. So then we got the pounds. First of all, the abbreviation for pound is LB. The reason for that, it would make sense for PD to be the abbreviation for pound. But at that time, the abbreviation in the bookkeeping for buying and selling grain, PD was already used as the abbreviation for paid. Didn't really want to get paid confused with pound. So they used the Latin word for pound was libra. So they used LB as the abbreviation for pound. Smaller than a pound we have ounces. Anybody know how many ounces are in a pound? 16. Good. Now, here's where most people's knowledge ends. By the way, the abbreviation for ounces is OZ. That also comes from the Latin word for ounce, which I can't remember right now. If they're going to use it for pounds, they use it for ounces too. Smaller than an ounce, we have grams or metric. Anybody know how many grams are in an ounce? Do I have to be worried about you guys? There's only been twice before in the whole time I've taught here that somebody's actually known that. One of them didn't finish the semester, ended up in Sawyer County.
I ain't going to jail.
Do I have to be worried? No, okay. Smaller than an ounce is actually a gram. It's actually, I believe it's actually 28.4, to be honest. Smaller than an ounce is a dram. There are 16 drams in an ounce. Grams almost sounds metric, doesn't it? Yeah. The word dram is actually where they got the word dram from. Drams were actually one of the original apothecary units. They might prescribe an eighth of a dram of a medication or something like along those lines. Smaller than drams. 1 pound, I don't know why they went back up to pounds, but 1 pound contains 7,000 grains. If you do anything with guns, you know, grains as far as bullets, gunpowder, stuff like that. Grains were actually just literally measuring out like the little grains of salt, counting them. So they might prescribe, you know, 100 grains of a medication or whatever. Now they've actually got them down into little measuring cups for grains. You know, this is a 50 grain measuring cup or a 10 grain cup or whatever. 10 grains is actually really small. The metric system was developed in the 1880s. So it's still drams. Drams still exist. It's very seldom used in everyday life. There's also something called a minim. A fluid ounce contains 60 minims. Those are all your apothecary, your medical units that were out there. There's a hundredweight, which is 100 pounds. The stone. Now this is one that's weird because a stone is approximately, if you ever watch like the World's Strongest Man competition, he's lifting 40 stone. A stone is about 14 pounds. Now, a hundredweight was defined to be 8 stones. So if you do the math there, that's 112 pounds. So it's another spot where, again, the stone was not originally 14 pounds. It's been adjusted to make it fit in. A hundredweight is defined to be 100 pounds. That's the standard now. You know, they don't use stones anymore, so we don't have to worry about the sloppiness in that conversion. But a hundredweight is 100 pounds. Now, something I want to mention before we move on is precious metals. You're talking about gems. Gems are measured in carats. Minerals are measured in carats. Diamonds, quartz, opal. Gold is a metal, not a gem. Carat, when you're talking about gold, is a purity. 24 karat is the purest form of gold you can sell for jewelry. Yeah. And then like 14 karat it's I don't remember exactly how the scale works anymore, but like a 14 karat is like 60% pure or something like that. 12 karat gold is 50% pure. Extreme. And it's usually gold that is alloyed with bronze. And bronze is a mixture of tin and copper. Now, it's weird because pure gold will not tarnish. The 24 karat gold does not tarnish. But the lower it gets, the more it will tarnish. Precious metals, gold, silver, platinum. You might hear on the news, gold reached $1,700 an ounce. I think they hit almost $2,000, $1,900 and some dollars an ounce, last I heard. They're not talking about an ounce like we're used to. You remember we talked about King Edward declaring his thumb and foot to be the official inch and foot of the land? Well, remember that it happened with several different leaders did that. Each ruler declared my thumb, whatever was going to be the official measurement. So around the world, from one country to the next or one region to the next, there were different units of measurement. And of course, the same thing happened with pounds and ounces. Well, for a long time, the center in the world for buying and selling precious metals was the island of Troy in the Mediterranean Sea, just off the coast of Greece. So what we use for precious metals is troy measure. Troy? So when we are talking about precious metals, there's something called 1 troy pound. TRLB stands for troy pound. And that is only about 0.82 regular pounds. However, 1 troy pound only contains 12 troy ounces. So while a troy pound is actually smaller than a regular pound, a troy ounce is actually larger than our regular ounce. But you might hear it, it sells for, you may even hear that phrase, $1,900 per troy ounce. That's what it is from the island of Troy. Island of Troy, by the way, is the fabled site of the mythical Trojan War.
That's where the Trojan War came from.
Yep. Yeah, the people of Troy were not Troyans, they were Trojans. You'll never be tested on this, by the way, but I just wanted to throw it out there just because you hear a lot about precious metals. Have actually, you haven't heard much about them lately because with the stock market climbing, usually when the stock market is climbing, gold and silver prices either stabilize or will slightly decline. It's when the economy looks like it's going to tank that gold prices go up. So, let's look at metric. In the metric system, we tend to focus on mass. So I'm going to put weight in here first. The unit of weight in the metric system is a newton. A newton meter is a force applied over a distance. It's a unit of work.
So newton pound.
A newton pound. Newton, that'd be redundant. Newtons and pounds are both measurements of force.
What's like the equivalent of like a foot pound?
A foot pound would be a newton meter.
Would it be a newton meter?
Yeah, I mean, we do it opposite. A foot pound is, the distance first, then the weight. A newton meter is the weight first, then the distance. But they both measure work.
Because my torque wrench has
Newton meters.
Has on one side it's foot pounds, on the other side you can just turn it and it has the newton meter thing.
Okay.
Pretty
Cool. So that's weight. Again, in the metric system, they tend to focus on mass. And their unit of mass is the gram, abbreviated with just a G. Now, we're not going to do much with grains in here, but a lot of people get confused because grains is abbreviated GR and grams is abbreviated G. It's really easy to see GR as your abbreviation. The first thing that's going to pop in your head is grams. Now, we've talked about how this metric system was a planned system. How 1 milliliter was designed to be 1 centimeter cubed. 1 centimeter by 1 centimeter by 1 centimeter was designed to be a milliliter. Well, 1 gram is defined to be the mass of 1 milliliter of water. And obviously it's distilled water because water does change slightly in density depending on the mineral content. Because of that, we can actually take a tank and we'll be able to find the mass of that tank by its dimensions if that tank is filled with water. 1 gram is the mass of 1 milliliter of water. So you can see they really did think about this metric system when they designed it. I know a lot of people will say, oh, darn metric system, I hate it. And it's because they're not used to it. And I was the same way. I was like, why would I do that? Because I was so used to working in feet and inches and pounds and ounces. But once you do learn the metric system and get used to it a little bit, it is so much simpler to use. Then, of course, smaller than grams, there's decigrams, centigrams, and milligrams. Larger than grams, there's decagram, hectogram, and Nate's favorite, kilogram. And as we mentioned before, we tend to use grams, tend to use milligrams, tend to use kilograms. The other ones tend to not get used much. They designed them all, but then in practice it never really got used. And the conversions are exactly the same. If you are given 4,100 milligrams, want to know how many grams that is? Well, milligrams to grams is 3 spots to the left, right? You got it. 1, 2, 3. 4.1. Now, if we keep going here, again, there's no 10,000 or 100,000. We skip to the millionths. That is microgram, or MCG if you want to abbreviate without the mu symbol. Micro, yep. That is used in medical fields. So there's some medications that are measured out in micrograms. DAG is deca. Gram. H is hectogram. K is kilo. On this end, of course, there's no 10,000 or 100,000 either. We jump up to a million, which is the megagram. 1 megagram is defined to be a metric ton. Now, more common than calling it a megagram, they usually just call it 1,000 kilograms. So 1,000 kilograms is a metric ton. 1 kilogram, by the way, is, this book says 2.2, but it's like 2.208 or something like that pounds. So you think about that, it's about 2,208 pounds. That's really close to your standard ton, and actually it's a little bit smaller than the gross standard ton. Yeah, mega. Which, like I said, we don't tend to use megagrams. We tend to use the phrase metric ton. So what's cool about all this, let's say you've got a gas tank that measures 40 centimeters, 25 centimeters by 12 centimeters. You want to find the mass of water that tank can hold. I just said gas tank, and I'm talking about putting water in it, but that makes a lot of sense. But you get the picture. So the volume here is 25 by 40 by 12. Which is what, 12,000 centimeters cubed if I multiply those together? $12,000 centimeters cubed, which is how many milliliters? See, 12,000. 12,000. Good. Which is how many grams? One cubic centimeter is 1 milliliter. 1 milliliter of water is 1 gram. So that's 1,200 grams, or 12 kilograms. water in there. Not so bad? Yeah, that's volume. So out of that packet I gave you, on page 238, 51 through 56 deal with standard weight. On page 266, 49 through 54 deal with metric mass.
In the packet?
In the packet, yes.